5.1 through chapters 5.1 through 5.3. Chapter 5 is focusing on systems of equations. Systems is a point that two equations will share. They intersect. They are solutions to both equations. Typically, when we have two lines, they intersect most of the time at one location. There are going to be special cases that we will go over in 5.4, but I will leave that for later. And in chapters 5.1 through 5.3, we learned three different techniques to do this. 5.1 is through graphing, 5.2 is through substitution, and 5.3 will utilize elimination. So solve the system by graphing. First thing we want to do is we want to get a coordinate plane out here. We look at our equations and we notice that they are in a linear form. This linear form is called slope-intercept form. We can pull out the slope and the y-intercept. We're always going to graph the y-intercept first. That's our starting point. That's a location. We know that that's a solution. And then we're going to utilize the slope, which is -3. Slope is typically seen as a fraction because it's rise over run. -3 as a fraction is -3/1. So -3 is down 3. 1, 2, 3. Run 1. +1 would be to the right. And we would do that. Keep doing it. We can go down 1, 2, 3, and right one more. Or we can put that negative in the denominator and make it +3 over -1. So rise 1, 2, 3, and run -1 would be left. And that's a nice way of extrapolating out points so we can connect the dots and sort of have a rough, not bad, rough view of what those solutions to that equation is. This has a y-intercept of -7 and a slope of 1. So we'll go to -7 and a slope of -1. Down 1, right 1. Down 1, right 1. Ooh, down 1, right 1. Did I do it wrong? Sorry. Slope of +1. So we get in this situation early. Mr. Mac making a mistake. We get into this situation early where it didn't look like it was going to intersect very well. So let's stop, let's reevaluate, and I noticed that I was implementing the wrong slope. Slope is 1, up 1, right 1, up 1, right 1, and that makes more sense. They should be intersecting. That is at a reasonably easy point. It shouldn't be that difficult. These answers are supposed to be working, so if it's not working, then we would definitely want to check and make sure that we're doing it properly. So in this case, when graphing, we tend to get whole numbers as solutions, and in this case, it would be 2, 1, 2, 3, 4, 5, 2, -5. And then we want to check it. If we want to get 100% on our assessment, then we're going to have to check each of those equations. We can take the time, and it only takes a matter of seconds to check our answer to make sure that -5 equals -5. And it does, and that's the first equation. And then we can do the green equation. And that equation is y equals x minus 7, plugging in -5 for y and 2 for x, and we get the correct answer. They won't always have the same solutions, but it works. Good, so my answer is 2, -5. Here's my next equation, two equations. Top one is in slope-intercept form, so I'm going to utilize the y-intercept, which is 3, and the slope, which is -4. 1, 2, 3, 4, down 4, right 1, down 1, 2, 3, 4, right 1, or I'll do the opposite, which is up 4, 1, 2, 3, 4, left 1. Taking that time to go in both directions just helps you. It saves you time later on. So we know what the slope is. We're pretty relevant. We can extrapolate it out. Now the yellow equation is in standard form. So we're going to use the cover-up method. And we're going to cover up the y term. And we get 4x equals 6. And then we cover up the x term and we get negative 2y equals 6. We're going to solve for those variables. We get x equals 3/2. That's my x-intercept where it crosses the x-axis. We're going to divide by negative 2 and we get y equals negative 3. That is my y-intercept. So let's make those points 1 and 1/2. 1 and 1/2. I almost made a mistake again already. And negative 3. 1, 2, 3. Okay. Now, doesn't look like we are going to extrapolate properly, but let's connect it. So where does it logically look like it's going to fall? Well, it kind of looks like it's going to fall there. So we would want to try it and we can check. I think the solution is going to be 1, negative 1, 1, negative 1. And the only way we're going to know if that is a solution is through checking. So it takes a couple seconds to check. We're going to use both of the equations. Y equals negative 4x plus 3, I think was my first equation. Plugging in negative 1 for y, plugging in 1 for x, and we're going to simplify. Negative 1 equals negative 4 plus 3. Negative 1 equals negative 1. So we know it works for the blue equation. We're going to do the green equation. 4x minus 2y equals 6. Plugging in 1 for x and negative 1 for y. Simplifying. And we get 6 equals 6. So we know that that is the point of intersection. That took 60 seconds. We're already through the first couple of problems. So the more efficient you are at this, the better it's going to be for you. We're going to look at this. The blue one, we're going to see that the x-intercept, that's in standard form, is 3. The y-intercept is also 3. We should be able to do the cover-up and do some mental math. We get that, make it blue, and we can draw that. We can do this relatively quick. So the x-intercept is going to be 5. The y-intercept is going to be negative 5. So x-axis 5, 1, 2, 3, 4, 5. The y-intercept negative 5, 1, 2, 3, 4, negative 5. Let's let's connect. Now let's use that color. Connect, and we get something that is relatively close. It's not too far of a stretch to assume that that would be our point of intersection. It's a good estimate. That goes 1, 2, 3, 4, negative 1. Whoa. 4, negative 1, and now we're going to check both of them. Check the blue, which is 5x plus 5y equals 15. 5 times 4 plus 5 times negative 1. That's 20 minus 5. 15 equals 15. And it checks out. Let's do the green equation. 2x minus 2y equals 10. 2 times 4 minus 2 times negative 1 equals 10. That's 8 plus 2. 10 equals 10. So I know my answer is correct. It's better to hand in your assessment knowing what your score is, knowing whether you got it right or wrong. Just my advice. Okay, look, you know, if you need to write this down, you need to rewrite it and do the intercepts so you can do some work. By all means, do it. Who cares? Take the time to do it right and to notate it. Negative 3/2, negative 3/2. 4x equals -3. Denominator, numerator cancels, you're left with -3. That's my x-intercept for the top equation. So x-axis, -3 is there. That's my y-intercept. Didn't even have to do any work. Super easy, very efficient. The more practice you get with these, the faster, more efficient you're going to be and less likely to make a mistake. Or, on the flip side of that, the more problems you do, the easier you are going to, when you find your mistake. You're going to know when you make a mistake. So with this equation, first thing that I have to be aware of is it's in neither slope-intercept form nor standard form. So I'm going to subtract, I'm going to isolate y, and that puts it in slope-intercept form. So now I can use the y-intercept and the slope. So the y-intercept is -8, and the slope is 4. 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. I'm going to keep going till I cross over. 1, 2, 3, 4, right 1. Easiest way to do that, keep utilizing the slope until you get to your point of intersection. If it's working, and that says 1, 2, 3, 1, 2, 3, 4, so that point, the solution to the system should be 3, 4. So 3, 4 is going to be my answer. I'm going to check it because I'm going to be consistent. -2/3 x, -2/3 x, plus y equals 2. Plugging in my x value of 3, plugging in my y value of 4. These cancel, -2 plus 4. 2 equals 2, that worked. And now I can use this equation. I can use y equals 4x minus 8, or I can use y plus 8 equals 4x. My y value is 4. My x value is 3. Does 12 equal 12? Yes, so I know my solution is correct. Write a system of linear equations with two variables that has a solution of that. Use a graph to justify your answers. Write a system. So I got to write two equations. So the easiest way is you pick coefficients. And then you plug it in. You plug your x value in and your y value in, and you simplify. So that's 8.4, that's -7.5. 8.4 minus 7.5 is 0.9. So I know that this equation is going to equal 0.9, or we can do 9/10. Doesn't matter. Well, let's do 0.9 because we have decimals. So that is one equation. Now I got to make another equation, and I just need to make sure it's not the same equation that I started with. So, or that equation 1. So let's do equation 2. Let's do -8. Oh, let's do 10. -10x plus 10y equals, I don't know what it is yet. I'm waiting. I'm plugging in those values and simplifying, and then I'll find out what it is. So that's going to give me -42. This is going to give me -25. That gives me -67. So this needs to equal -67. So now I have two equations. I'm going to use technology to see, to make sure that that is my point of intersection. So we're going to use Desmos, and we're going to plug in both of those formulas. 2x plus 3y, 2x plus 3y equals 0.9, and then -10x plus 10y equals, and what did we say? -67. So 4.2, -2.5, yeah, that's what it said. That's what, well, let's move this over a little bit. so we don't have to take that big of a picture. And we'll take a picture, and so that was a solution to the system. Or those two equations act as a solution to the system. We got to make sure we get that same value. And it's really easy. We leave this right side open until we plug in. We pick any two coefficients. I picked 2 and 3 for this one, -10 and 10. It does not matter. It's a real nice, easy way of finding two equations using your solution. So they have to be true for both of them. That's why. The graphs of two equations in a linear system have the same x-intercept. One equation is in the system is blah, blah, blah. So what is the solution to the system? Well, the x-intercept is going to be, if we use the cover-up method, we'd solve for x equals 5a. So the coordinate would be 5a comma 0, because you're plugging in 0 for y and getting that. So the graphs of two equations system have the same x-intercept. One equation is this. What is the solution of the system? Well, since they have the same x-intercept, that's going to be where they intersect. So we just know it's in standard form. And to find the x-intercept, we do the cover-up method. So that's how I got that, 5a comma 0. That's actually a pretty simple question. You plant a spruce tree that grows 4 inches per year and a hemlock tree that grows 6 inches per year. The initial height of the trees are shown, the initial height. All right, so let's do spruce in green. Let's do hemlock in blue. So green is going to be y equals, spruce is growing at 4 inches per year, and it started at, inches, making sure the units are correct. And then the hemlock, we're going to write in blue. Hemlock is going to be y, and it grows at 6 inches per year, and that starting is 8. That's that intercept. Okay, you plant. The initial heights of the trees are shown. After how many years will the trees be the same? So what is the intercept? So we can graph them, and it would be the graph of its height. Height being in y, this is going to be y, which is height. Producing, the output's going to be the height, and the input, x, is going to be, what are we dealing with, years, yeah. So that's okay. It shouldn't be green. That should be, let's make that in black. Not to confuse that one is different than the other. Those are just the units. Now we're going to graph in color. So, all right. You see what the problem is. We'll go by twos. We'll go by twos. Do we want to go by twos? So we're going to get a little complicated, but it's okay. So 2, 4, 6, 8, 10, 12, 14. And each increment is 2. So if we have a slope of 4, we're going to go up to right a half. Know what I mean? Jelly bean. And we're going to have to move this a little bit. Let's move it down a little bit, because we're going to go off the chart. Let's put that over there. So if we want to go again, it's going to be up 2 increments, which is 4 years, or 4 over 1, 4. So we'll go there and here. So each increment is 2. Let's go green. We're in green. We're going to extrapolate it out. Now we're not going to go negative because the tree's not going to shrink. So I don't care about to the left of years. So this is after 1 year, 2 years is what we have now. 8, 2, 4, 6, 8 inches. And 6 is going to be 2, 4, 6, 1 year. 2, 4, 6, 1 year. Right. 2, 4, 6, 1 year. All right, so maybe we're going to have to, oof, Mr. Mac made it so hard. He needs a bigger graph. So 1, 2, right, 2, 4, 6 over 1. Yeah, that's good. And then if we keep going with blue, it's going to be 2, 4, 6 over a half. 2, 4, 6 over. All right, so maybe this is my point of intersection. So that looks like it's going to be a half. I could be wrong, but we'll see. This is why graphing isn't great. So if each year is 2, so that's going to be 3 years, and that's going to be 2. We got. Did I do that wrong? No. We'll see. 14. 2, 4, 6, yeah. So 14, 16, 18, 20, 22, 24, 26. Now, we don't know. We're guessing because our graphing is not exact. So we can still do this by checking. Checking still works. We can use the equation. Let's use green first. Y equals 4x plus 14. Plugging in does 26. That's the height. 4 times 3 years plus 14. Does 26 equal 12 plus 14? 26 equal 26? Yes, so that worked for the spruce tree. Now we got to try for the hemlock. And the hemlock formula is going to be y equals 6x plus 8. So let's check. Does 26 equal 6 times 3 plus 8? 26 equal 18 plus 8? 26 equal 26. Yeah. So after 3 years, both trees will be 26 feet. Feet? Inches? Inches. Which is just under 3 feet. Okay. I like it. That's when they're going to be the same height. We got that. What number is this? 7? Going through, didn't even check to see. I'm assuming my answers are correct. Let's see, 3 years, 26 inches. Yeah, let's go. All right, 5.2. 5.2 is going to use the substitution. Substitution, not always, we have to isolate. We tend to isolate one variable, and we're going to substitute it back into the other equation. So my equation says 3x, instead of writing y, we're going to write what y is equal to in terms of x. So that's 8x plus 7 equals -9. Let's move, and we're going to isolate because now we only have one variable, and that's our whole objective is -2. Now we can go back to this equation, y equals 5. Instead of plugging in x, we use -2. Y equals -10 plus 7. Y equals -3. So my solution should be -2, -3. And I'm going to check with the other equation, with that top one. So my checking, I only need to check the top equation because I used the bottom equation. 3x plus y equals -9. plugging in -2 for x, -3 for y. 3 times -2 is -6 minus 3. -6 minus 3 is -9. And it worked, so I know my solution is correct. Now, neither equation is simplified for a variable. I am going to, you must, if we're going to use, you must use substitution. I'm going to make sure that you use substitution. You can't use addition. You can't use elimination through addition, subtraction, or anything of that nature. You must use substitution. I'm going to check your work and make sure that you are using substitution. Also very important, we can't substitute it back into the original equation. We must substitute it in to the other equation that we haven't manipulated. So x equals y plus 1 plus 4y equals 6. We're going to simplify before we move. We have y and 4y on the same side of the equation. We're going to minus 1. 5y equals 5, divide by 5, y equals 1. Now I can go back to this equation. Y is 1, so x is 2, 2 comma 1. Make sure you write your equation x comma y in a coordinate. That's the other thing I haven't mentioned. Your solutions must be a location, must be a coordinate. And now I'm going to go back to my checking. I'm going to check, I think I'm going to check x plus 4y equals 6. So we have 2 plus 4 times 1 equals 6. 2 plus 4 equals 6. 6 equals 6. And that is my checking process. I'm going to subtract 3x and get y equals -3x plus 6. I've solved for y, and I'm going to substitute -3x plus 6 into the other equation for y, for the y value. So this equation now becomes 2x plus 3 times -3x plus 6 equals 4. We're going to distribute. That's how we're going to simplify. 2x minus 9x plus 18 equals 4. Let's simplify those. -7x plus 18 equals 4 minus 18. -7x equals -14. Divide by -7. X equals 2. Plug it back into this. -3 times 2 plus 6. Y equals -6 plus 6. Y equals 0. So my solution is 2, 0. And I'm going to check using 2x plus 3y equals 4. 2x plus 3y equals 4 for my check. So 2 times 2 plus 3 times 0 equals 4. 4 plus 0 equals 4. 4 does equal 4. So I know my answer is correct. All right, our first word problem. You spend $20 total on tubes of paint and disposable brushes for an art project. Tubes of paint cost $4 each. Brushes cost 50 cents. You purchase twice as many brushes as tubes of paint. How many brushes, how many tubes of paint? So we have two statements that we have to write. One of those statements is you purchase twice as many brushes as tubes of paint. So I know that I'm going to have more brushes than tubes of paint. So my brushes are I'm going to have to double my tubes. I know that sounds counterintuitive. Well, why am I doubling the tubes of paint? Aren't I supposed to have twice as many brushes? You are. But understand that if I have 20 brushes and 10 tubes of paint, Notice if I want to make them equal, I have to multiply the smaller to make it equal. Because I'm making a statement where they are going to be equal, I need to double the smaller to equal the bigger. Just intuitive. That's something you're going to have to work on. And then my other equation is I spend $20 and the tubes of paint. So I know that if I want to find the total cost of thing, I'm going to take the cost for the paint tubes. So it's $4 for each tube. So if I multiply 4 times the number of tubes, I will get the total cost of the paint. And then if brushes cost 50 cents, I'm going to multiply the cost times the number of brushes, and that will be the total cost that I spend on brushes, and then I know I have a total of $20. So intuitively, it tells us, hey, we should use substitution. We've got a variable that's isolated. Let's plug it back in to the other, the other equation. Let's plug it back into the other equation. So we're going to take that value and we're going to plug it in for b, which gets rid of one of our variables, 4t plus 0.5 times 2t equals 20. 4t equals, or plus t, half times 2 gives us just t equals 20. 5t equals 20. So notice that I'm solving for t, which is the number of tubes. So when I get t equals 4, I purchased 4 tubes of paint. And then if I want to find how many brushes, I can use this. Brushes equals 2 times 4, because I purchased twice as many, so I purchased 8 brushes. So 8 brushes, 4 tubes of paint. I have twice as many brushes as tubes. And if I multiply 8 times 50 cents, that's going to be $4. And if I have, if I purchase 4 tubes of paint, 4 is 16. 16 plus 4 makes $20. Boom. All right, 5-3. Now we're going to use elimination. So elimination still is very much like substitution. Substitution, we wanted to eliminate one of the variables, because having 2 variables, we're never going to be able to know what the solution is. So if we add them together, we'll notice that if we, first of all, they have to be in the same format. Here we are ax plus by equals c, and we're going to combine the columns. So we'll combine the x's, combine the y's, and combine the constants. And notice each of the equations are on the same, in the same format. The y's cancel, and we're left with 28 divided by 14, x equals 2. We'll take one of the 2 equations, and we'll substitute my x value, which again gets rid of one of the variables. We only have one variable left, so that will allow me to solve for it. Minus 18, negative 2y equals, what's that, 16 divided by negative 2, and we get y equals negative 8. So my solution is going to be 2, negative 8. Let's check my solution. I'm going to check with the other equation, 5x plus 2y equals negative 6, I think it was. This is my checking. I'm plugging in 2 for x, negative 8 for y, making sure that when I simplify the left side, I get the right side. I'm not moving, I'm simplifying the left side, simplifying the right side. So that worked. elimination. So with this problem number 13, they set it up. And notice none of them are eliminated. If we added the columns, they are in the same format, which is important. That's the first thing I'm checking. But if I add the columns, neither cancel. So I have to pick a variable that I want to cancel. Well, I see I have positive 6y and I have negative 3y. I need this to be a negative 6y in order to cancel with this positive 6y. So I can manipulate this equation. I can write an equivalent equation, not negative 2, Mr. Mac, positive 2. If I multiply that entire equation by positive 2, I get 4x minus 6y equals negative 38. Make sure you multiply all three terms. That's where you're going to make your mistake. And then I'm going to bring this equation. I don't have to manipulate it at all, because now we notice, looking at our columns, our y's are going to cancel. We're left with 5x equals negative 10 divided by 5, x equals negative 2. Go back to one of these equations. We're going to use this to find my y, plug in my x value, which eliminates one of the variables. I'm only left with one variable, so that tells me I can solve for the variable y. Divide by 6, y equals 5. So my solution should be negative 2, 5. I'm going to check by using the other equation, which is 2x minus 3y equals negative 19. Plug in my x value, plug in my y value. Does it equal my right side? Negative 4 minus 15. Negative 4 minus 15 is negative 19. Does negative 19 equal negative 19? It does. Same thing here. We are going to have to manipulate it. So we have to check what equation. So if you listen to the extra practice, every single example set it up where one of the variables were opposite signs. And this one, x's are the same sign and y's are the same sign. So I'm going to have to manipulate. First of all, what do I want to get rid of? Well, 6 and 8 have a common multiple of 24. 5 and 6 has a common multiple of 30. So I just have to choose which variable I'm going to get rid of. I'm going to make it more challenging. I'm going to get rid of the x's. And I'm going to think of 24. So if I multiply 8 by 3, I get 24. X minus 18y equals negative 9. Now, if I'm going to get rid of my x's, I need this to be negative 24. So I'm going to have to multiply by negative 4 here. That gives me negative 24x. That's plus 20y equals positive 4. So my x's are going to cancel. I'm left with 2y equals 5? Negative 5? Did I do that right? Wow. What number was this? 14, 15? Let's just make sure that I'm on the right path to success. Oh yeah, I am. Don't question yourself, Mr. Mac. Be confident. Negative 5 halves. All right, now I'm going to choose one of these equations. I'm going to choose the bottom one. 6x minus 5. My y value is negative 5 halves, which is making it even continue with the ugliness. 25 halves, negative 1. We're going to subtract 25 halves. We're going to make negative 1, negative 2 over 2 in halves, so we can combine it with that negative 25 halves. 6x makes, wow, it would have been nice if it was friendly, but it's not. Then we are going to multiply by 1/6. 1/6 we get x equals, we can cross cancel, 3 goes in that 2 times, 3 goes in this 9 times. So we get negative 9/4. Negative 9 times 1 is negative 9, 2 times 2 is 4. So well, not solution set, right, is a coordinate, negative 9/4, negative 5/2. Negative 9/4, negative 5/2. I can check, yes, I'm going to do it even though it's going to be painful. 8x minus 6y equals negative 3. Stay with it. X is negative 9/4 minus 6y is negative 5/2 equals negative 3. So these cancel. 2 times negative 9 is negative 18. A negative times a negative is going to be a positive. There's 2 in the denominator, cancels with that, and I get 15 equals negative 3. Negative 3 equals negative 3. So my answer is correct. Last one, 108 on a Monday, President's Day. In a football game, all the home team's points are from 7-point touchdowns and 3-point field goals. The team scores 6 times. Find the number of touchdowns and field goals that the home team scores. So hopefully you see this. So touchdowns plus field goals. These are the number of touchdowns and the number of field goals. Those are the times we score. Scoring, touchdown scoring is 6 times. So these are scoring opportunities. And then we know that touchdowns are worth 7 points. Field goals are worth 3 points. And they scored a total of, find the number of times field at the home team. Home scored 26 points. Right here. Home team. All right, now we can either use substitution or elimination. Let's use elimination. So I'm going to multiply this by negative 3. I'm going to get rid of the f's. So I get negative 3t minus 3f equals negative 18. Bring this equation, 7t plus 3f equals 26. The f's cancel. That's left with 4t equals 8. 8 divide by 4, divide by 4, t equals 2. So I scored 2 touchdowns, 2 7-point touchdowns, and going back to t plus f equals 6. So t is touchdowns, and there are 2. How many field goals did I score? I scored 4 field goals and 4 3-point field goals. I like that. Scored 2 7-pointers, 2 touchdowns, 4 field goals. Awesome job. Hopefully that helped you. Make sure you're prepared. Attack for the assessment. Good job.